Welcome family. Lot of structural engineers after analysis directly proceed to design. That is a mistake. Today I will show you 4 pre-designed checklists for 20-story apartment building in CSI ETABS software. The first checklist is that irregularity check. That is all about planning elevation irregularity. It influences the analysis method and that of a safety factor as a whole. And the second point, that's all about building classification. That is to determine the behavioral factor Q. That's control the project cost and all over that of the project performance. As an example, if you have a higher value of Q or that of behavioral factor, it means that we have a lower design ratio, and it implies we have a smaller cross-section or structural element. And the third point is that damage limitation. Damage limitation is all about protects non-structural element. And the fourth checklist, that is all about P delta effect, to consider the second order effect or second order analysis, and totally it ensures the building stability. After discussing all these 4 checklists that we are going to do after analysis and before proceeding to the design, so we will prepare Excel sheets for all these 4 checklists together. In this tutorial part, we will focus on damage limitation. Watch up to the end and don't forget subscribe the channel, like this video, and finally you can drop any comments, maybe your question or suggestion for next video. Thank you for your support. Let's start today's tutorial as tutorial part 1 on damage limitation or that of drift. That is what our model looks like in CSI ETABS software for a 20-story apartment building with 3 basements, and this is the Excel template sheet for damage limitation or drift. We are going to prepare together for all stories and all load combination in X direction. So all things are listed like this. Let's proceed to prepare this Excel template sheet together. Our model is locked. It implies the analysis is done. But before proceeding to design all these structural elements, we are going to check all the 4 checklists that I've told to you before. So before that, let's check the period to distinguish or to determine the analysis method. To do this, let's go to the display menu here, show table. Let's go to the analysis results. So structural output from this modal information. So let's check the modal period and frequency. From this, let's select all the load patterns and the load case. After that, let's clear all, and let's select the static load combination only. So let's check the period for the static load combination only. Gravity, seismic for gravity, and all the wind load combination plus the service. Make it okay. After that, make it okay. Our period is greater than 2, so static analysis is not selected for this project. So let's use dynamic analysis or response spectrum analysis method. So let's make it done. After checking the period and that of analysis method, let's proceed to check for damage limitation or that of story drift. So let's go to the display option, show table again. From this, let's uncheck this box. So let's go to the joints outputs here. So displacement. Let's check the story drift. After that, let's select the load pattern. So I don't want any load pattern. So let's make it okay. And I don't want also any load case. So let's clear it. Load combination. Let's select the dynamic one. All the dynamic one, but to show you or to save our time, let's use the first response spectrum analysis, that is the X direction govern the all the load combination. So let's select this load combination with the X direction is governing. So let's make it okay. After that, make it okay. In this case, I have get all the drift value in X and Y direction for the selected load combination. But in your case, you have to select all the load combination that the X direction is governing. After that, you have to check with the limit that the drift in X direction. And in similar way, you have to do for all the load combination in Y direction. So to save our time, let's filter all these drift values. Let's select the maximum value, or let's filter the maximum value of drift for each story. After that, let's select the direction, as this load combination is the governing one is in X direction, that's 100%, and 30% in Y direction. So the drift is maximum in X direction. So this is the drift in X direction. So let's filter to X direction. Yeah, like this. This is the drift for all floors for this load combination in X direction. Or let's export this value to Excel sheet. After that, let's check, or let's limit with Eurocode standard. So let's go to the file menu here. Export a current table to Excel. The export is ready. So let's check the Excel templates that ETABS software give for us. Let's zoom it. So this is Excel template sheet for the story drift. So let's check the story drift. This is all the stories, and this is the load combination that we are going to select. The drift calculated by ETABS software in X direction with the maximum value is like this. This drift is calculated by the ETABS software itself. Using this elastic drift value, we are going to calculate our design drift, that is by multiplying by the behavioral factor that we are going to get by classifying our building. After getting design drift, we are going to limit our design drift using that of Eurocode standard. So I don't want all this value. So let's cancel this cell. So let's delete it. So let's enter the value of IQ, that is the behavioral factor, and let's cancel this unit. So let's cancel this value. Let's cancel. So let's copy the cell again. We want the cell. So let's copy. After that, let's enter the behavioral factor value that we're going to calculate before. That is 3.12. So let's drag it to calculate the design drift, that is there. So design drift is equals to that of elastic drift times behavioral factor. So this is our design drift for all stories. After calculating our design drift, let's enter the value of V, that is the reduction factor. Our project is building class 2. For building class 2, the reduction factor value is 0.5. And if our project is class 3 and 4, we can use reduction factor value V of 0.4. So let's drag all this value to the other stories. So let's make it at the center. Yeah, let's make it as a center. In similar way, at this direction also at the center. After getting or calculating all the design drift value and that of reduction factor value for our project, let's proceed to the limiting area as per Eurocode standard. So limits. Let's write as limit. So we have three limiting parameters. The first parameter is that 0.01 divided by V. So this is the first limiting value, and the second limiting value 0.005 divided by V, and the third limiting value 0.0075 divided by that of reduction factor value V. Let's go to define all these values. So the first value, that is 0.01 divided by V, Eurocode standard recommends that we're going to use this limiting value if the non-structural part of our project is constructed as in separate way with that of structural part. So we can use this limiting value. That means our design drift must be less than this value. That means, and in similar way, let's use this value 0.005 divided by V when your non-structural part is a brittle material like a partition wall, that's brick, or that of glass. And you can use this value as a limiting value. If your non-structural element is a ductile material, you can use this for a steel structure design. So the governing one is this value. So our drift must be, let's check that our design drift, our design drift must be again less than or equal to that of 0.05 divided by V. Yes, 0.05 divided by V. Let's cancel all this value. Let's cancel. This is our limiting value. So let's calculate that our limiting value 0. Which is equal to 0.005 divided by V. That means this value. Yes, let's drag it to the other stories. So let's make it at the center. Let's go to the checklist. So let's copy all this. Right click here, then let's paste it. So let's make it check. Let's make it check if drift less than or equal to the limiting value. So make it okay, which is equals to if yes, let's select this. If our drift, that is this value, this value less than or equals to this value, less than or equals to this value. So make it okay, make it okay. Otherwise, not okay. Otherwise, not okay. So let's close the bracket, enter. So let's drag to the bottom. If the value is greater, you have to go back, or you have to increase our section, column section, or you have to provide a shear wall. So after that, you have to return back to the first step. That may be classifying the building and so on. So if all the load combination makes okay, or if the damage limitation pass this limiting value, you have to proceed to the next. This is all about today's tutorial. Next, we are going to check the other checklists. So I will share this Excel template sheet for you on my Telegram channel. Don't forget subscribe this channel, like this video, and share to your friend. Have a nice time. Thank you.